Welcome dear students to video number 3 for standard 10 geometry chapter number 3. In the previous video we started with practice set 3.1 and we discussed question number 1 and question number 2. Now let us start with question number 3. Segment RM and segment RN are tangent segments of a circle with center O. Prove that segment OR bisects angle MRN as well as angle MON. My dear students, while writing this in your notebook, you need to write the given information and to prove. So what's the given information? We have a circle with center O and segment RM and RN are its tangents. We have to prove that angle MRO is equal to angle NRO and angle MOR is equal to angle NOR. So let us start with the proof. So here we have in a triangle RMO, this triangle, and triangle RNO, this triangle. We have angle, just a minute, okay, this angle RMO is equal to angle RNO. The reason is they are 90 degrees according to tangent theorem, and the hypotenuse is common to both OR as well as OR. The reason common side, and side OM is congruent to side ON. Both are radii of the same circle. So according to this, I can say that triangle RMO is congruent to triangle RNO by hypotenuse side theorem. And once the triangles are proved as congruent, I can say that the corresponding angles, these angles, this angle MRO is equal to angle NRO and angle MOR is congruent to angle NOR. The reason for both is corresponding angles of congruent triangles. So once the angles are proved congruent, I can say that OR bisects angle MRN and angle MON. Now next, my dear students, question number 4. What is the distance between two parallel tangents of a circle having radius 4.5 centimeters? Justify your answer. So we have to begin by drawing the figure. So this is your figure for reference. I have a circle with center O. I have a tangent to it. Tangent line AB is my tangent. The meeting point is point M. Another tangent I draw on the other side is line CD. The meeting point is N. And I know that these two tangents are parallel. It's the given information. I have to do another construction over here, and that is draw a line parallel to both the tangents in between, passing through the center. So that is my line XY passing through center and parallel to line AB and parallel to line CD. So this is my figure and the construction. Now next, I'll just quickly go through whatever I explained to you just now. Let the center of the circle be O. Let the tangents AB and CD touch the circle at points M and N respectively. Draw segment OM and segment ON. Through O, draw line XY parallel to line AB. Now it is given to us that line AB is parallel to CD. and line XY is parallel to AB through construction. So I can say that line AB parallel to line XY parallel to line CD. So this much is understood. Now let's move on. Now angle OMA is equal to angle ONC. So here we have OMA. So this angle is equal to angle ONC. This angle and this angle both are 90 degrees. The reason? Tangent theorem. And line AB is parallel to XY and MO is the transversal. So now I can say AB is parallel to XY according to construction and MO is my transversal. So now I can say that angle OMA, that means this angle, plus angle MOX, this angle. So these two angles when I add, I get the addition as 180 degrees. The reason? They form interior angles. So we know that interior angles are supplementary. So the reason, so that is what I have written over here. Interior angle theorem. But I know the value of angle AMO, that is 90 degrees. So when I substitute, I get the value of MOX as 90. 180 minus 90, which is 90. MOX as 90. So I can say, similarly, I can prove NOX also as 90. This angle and this angle is 90. That means when I add both, I get 180, which says that they form a linear pair. Now they are forming a linear pair and they are adjacent angles as well. That means, so they are adjacent as well as supplementary. That means they form a linear pair. And ray OM and ON, this ray OM and ON, both these rays are opposite rays, which tells me that points M, O and N are collinear. That means they are in a straight lines. So therefore this MN is the distance between the parallel tangents AB and CD. Therefore the distance between line AB and line CD is nothing but this MN, this entire distance MN. But we know that OM, which is the radius, is 4.5. That means MN would be twice the radius. That means 2 multiplied by 4.5, which is 9 centimeters. So my dear students, your final answer is 9 centimeters. The next concept is touching circles. Now what are touching circles? If two circles in the same plane intersect with a line in the plane in only one point, they are said to be touching circles and the line is their common tangent. The point common to the circles and the line is called their common point of contact. Now here are two examples. In figure 3.24, the circles with center R and S touch the line L in point T. So they are two touching circles with line L as common tangent. They are touching externally. And in figure 3.25, the circles with centers M and N touch each other internally and line P is their common tangent. K is the point of contact. On the basis of this, we are going to discuss a theorem. This theorem is called as Theorem of Touching Circles. What does it say? If two circles touch each other, their point of contact lies on the line joining their centers. So I have two figures over here. In the first figure, I have two circles with centers A and B. Line L is the tangent and C is their point of contact. And in second figure, now in first figure, the circles touch each other externally. In second figure, I have two circles with centers A and B. Line L is the tangent, point C is their point of contact. These circles touch each other internally. Now what do we have to prove? That point C lies on line AB. Let us start with the proof. Let line L be the common tangent passing through C. Of the two touching circles, line L, we know that line L is perpendicular to AC because it is a tangent. And line L is also perpendicular to BC because it is a tangent to the other circle also. So therefore, I can say AC is perpendicular to line L and BC is perpendicular to line L. Now through C, only one perpendicular to line L can be drawn. We know that when a point and a tangent when a tangent touches a circle, through that point only one line can be drawn. So therefore, I can say that points C, A and B are collinear. That means these 3 points lie in a straight, they are on a straight line, which proves that point C lies on line AB. So on the basis of what we discussed just now, you have to remember this. The point of contact of the touching circles lies on the line joining their centers. If the circles touch each other externally, distance between their centers is equal to the sum of their radii. And the distance between the centers of circles touching internally is equal to the difference of their radii. These will be used to solve sums in the next practice set. My dear students, this is all for now. We will meet in the next video. Till then, have a nice day. Thank you for watching.